Hey folks, so this is going to be a video that deals with triangle congruency. It's a pretty important video, so stay tuned. This is in section 12.1. Let's go ahead down a couple pages until we get, first of all, to the definition of congruent triangles. So the first thing to notice is that the first two words here, if triangle ABC is congruent to triangle DEF. One thing to notice is that the order of the letters makes a big difference. So pay attention to the order of the letters. This is saying that point A is always going to correspond to point D. Point B and point E are always going to be corresponding points, and point C and point F are always going to be corresponding points. So that's going to matter a lot in the upcoming days. So let's continue reading. It says if two triangles are congruent, then the corresponding angles must be congruent. So let's take a look. The first line here says that angle A is congruent to, well, what point corresponded to A? That's going to be point D. So angle A is congruent to angle D. In the same way, angle B is going to be congruent to angle E. Angle C is going to be congruent to angle F. But not only are my corresponding angles congruent, I'm also told that my corresponding sides are congruent to each other. So then let's go ahead and look at the next statement in this fill in the blank. It says that segment AB, now segment AB has to correspond to segment DE. So that's what I'm going to write here. Segment BC is going to be congruent to segment EF, and then segment AC is going to be congruent to segment DF, always keeping my corresponding points in the correct order. Two theorems to look at is if you are told that you have, in the first case, three sides of a triangle congruent to three sides of another triangle. So what I want to draw here for you, first of all, is just let's go ahead and draw a pair of triangles. And maybe my triangle looks something like this. And let's make this a little bit unique here. And let's have a second triangle. And let's say that we're told here that this side is congruent to this side. Maybe this side is congruent to this side. And thirdly, this side is congruent to this side. Maybe we're told this information. According to this theorem, if the three sides of one triangle are congruent to the three sides of another triangle, then what must occur is that the triangles must be congruent. The second theorem is very similar to that, but notice that I have a different set of known pieces of information. So again, let's draw another triangle, and let's see here. Let's copy. And so let's say that maybe now I'm told that, take a look, it says two sides and an included angle of one triangle. All right, so let's take this one at a time. Let's say that I know that this side is congruent to this side. So there's one pair of sides congruent. And then I'm also told that maybe another pair of sides are congruent. So that takes care of the two S's in my little acrostic there. So two sides of a triangle are congruent to two sides of another triangle. But then I'm also told that the included angle. All right, so what does that mean? Well, you'll see that I have the two sides marked. The included angle is going to be the angle between the two sides. The angle between. So this right here would not be an included angle, while the angle that I've marked is an included angle between the two sides. So we've got the two sides and the included angle are congruent to the two sides and the included angle. And what's going to happen here, if I know this information, then automatically my two triangles are congruent to each other.